All of these other galaxies are gravitationally bound to this galaxy cluster. So they're all buzzing around this giant galaxy like bees buzzing around a hive.
These clusters are the product of galactic cannibalism on a cosmic scale. This computer simulation shows how a galaxy cluster evolves in a dense region of the universe, tens of millions of light years across. Hundreds of galaxies form, then swarm toward a common center. A central galaxy swallows them up. As it grows, so does the black hole. McNamara is searching for the monster's paw print.
So that's a giant galaxy sitting in the middle of a cluster of galaxies. So the idea is that that's a big galaxy, and right down at the center you can't see it. We think there's probably a black hole that's got a mass that approaches 1 billion suns. It very recently, in the last several tens of millions of years, gobbled up a lot of matter, and it caused a huge eruption.
McNamara zeroes in on a distant galaxy cluster, 2.5 billion light-years away. Called MSO7, it's hidden in a vast cloud of hot gas.
There's an atmosphere of gas that pervades the entire galaxy cluster. And it's an atmosphere like our atmosphere, except that it's far less dense and it's much, much hotter.
McNamara noticed that 2 immense cavities in this cloud had been hollowed out.
In that cavity here, and this cavity here, we could stuff 600 Milky Ways in there. It's just astonishing. The energy involved is huge.
McNamara believes this eruption of energy is the most powerful since the Big Bang itself. He traces its source to the core of the giant central galaxy, a supermassive black hole. But how does a black hole, a creature famous for devouring everything within its grasp, spew energy across the universe?
As matter falls in, what we know now is that it spirals around in a disk, okay, very much the way when water goes down the drain. And the speeds that matter can achieve around that black hole approach the speed of light. And when matter travels at that speed, it gets a tremendous amount of energy.
Matter falling into a black hole is a lot of stuff trying to get into a very small place. And so it's like trying to fill a dog dish with a fire hose. Most isn't going to get in.
A high-speed whirlpool of matter coils around the black hole, creating a powerful magnetic field that hurls enormous volumes of gas outward. It produces a powerful jet of matter, hundreds of millions of times the power of the sun, that blasts right out of the galaxy.
There's no question that the black holes at the centers of galaxies have a profound influence on their surrounding. They send out these huge jets moving at almost the speed of light. And those jets can send shock waves into the surrounding medium, change their surroundings completely. They have a dramatic influence.
These jets can literally sterilize the galaxy by halting the formation of new stars.
In principle, galaxies can grow to very, very large sizes, and what we see in the universe is that they don't. And we think that the supermassive black holes at the center may be the culprit. They may be responsible for preventing runaway growth of galaxies.
In smaller galaxies, all this violence can have a creative impact. Black hole blast waves spread heavy elements generated in the core of the galaxy, setting the stage for the formation of new solar systems.
We usually think of black holes as God's dumpster, but they really are actors on the galactic stage.
The monster of the Milky Way may have helped create our solar system, but what's to stop it from wiping us out? It all depends on the monster's diet.
One of the key differences between galaxies with supermassive black holes is whether or not their black holes are lit up, because they're basically binging on a lot of material in its surroundings.
For years, Our own black hole has probably been fasting. But in 1999, the Chandra Space Telescope detected a powerful signal from the galactic center.
Station 3-4, Chandra OC. Just to let you know, we have about 18 minutes remaining in the playback.
An explosion just
to get a
outside the
final
event
count.
horizon. For the galactic center teams, the blast is a wake-up call.
It was a hot piece of news at the time. A remarkable fact for all of us was, and for many years, how inactive the black hole was.
Bit of a puzzle that there's so many of the blue stars on that side, not on that side. But
Now, both Reinhard Genzel and Andrea Getz race to their telescopes. They will try to see whether the black hole's about to binge. The two teams join in a worldwide effort. 5 major observatories will probe the black hole. From space, the Chandra X-ray Observatory will watch for high-energy light. Reinhard Genzel heads to Europe's very large telescope, set in the high desert of Chile. Andrea Getz climbs Hawaii's Mauna Kea volcano to the legendary Keck Observatory.
When you're there, it's an incredible rush. I mean, you're very much on for the few nights that you're there, hoping that your experiment works, hoping that the weather cooperates.
Telescope time is precious. There's no room for mistakes.
Madeline, we're ready to go? Right.
The teams have 5 short nights to find out how much the black hole is eating by measuring the energy that flares out. Night 1, the Chandra headquarters in Cambridge, Massachusetts.
Zoom in a little bit more. All right, so first night. Doesn't look like we've got any flares.
The telescope turns up only noise, X-ray flashes from small black holes roaming through the galactic center.
4 more chances, guys.
Night 2, the telescope in Chile has problems.
Can I see the monitor, the correction?
it's still not very much there. Well, we do need to sacrifice now someone here to to the gods or something like this. Should I volunteer?
Even if there are flares, the very large telescope can't see them.
We redo the acquisition, or we redid the acquisition.
What's happening?
It was, the correction was,
Unstable.
yeah,
A
unstable.
patch of humidity is warping the delicate optics. Everything's a blur.
We have to check something because we look at the guide star. It's extremely.
Okay, now we have a problem with the 8 meter, with the main mirror. The 8 meter mirror seems to be deformed.
In Hawaii, it's not much better. The galactic center is playing hide and seek behind overcast skies.
We're fighting with clouds. It looked better just a moment ago, so it looked like we were just ready to go, but now it's looking like.
Finally, on night 3,
Right.
It's really flaring.
the German team's luck changes. In Chile, they spot an
It has been
outburst.
going on for more than an hour already.
That's the best flare event that we saw during this run.
So we have these
A new
2
point of
main
light
targets
appears in the
which are
star
solid
field,
typically
one that
down.
wasn't there before.
Which is set.
So here we clearly see that there's basically no source at that position between those 2 blobs. On the other side, we have the same region, and we clearly see that they're the same 2 sources, and now in between we see an additional source. So this is a flaring state.
When the Chandra team receive their data from space, they can see it too.
Oh, all right. All right, here we go. Ah. Oh, yeah. There we go. That's huge. All right. That's at least 0.0. All right, so that's at least a factor of like 15 or so. So let's pick
The
this background
X-rays
over
show
here.
a spike that coincides with the flash of light captured by the
So that's a
Germans.
factor.
News from our colleagues, of course, telling us that they are few hours further west. So the sun hasn't even set yet.
The stars of the galactic center haven't yet risen above the Hawaiian horizon. Getz has missed the flare.
This part kills me. Waiting.
But the next night the team gets what it's looking
Well, I
for.
like that image a whole lot better.
This is it. Yeah. Really?
We were taking measurements, and you didn't see anything from the black hole. All you saw was a star, and then bam, it was there and bright. And 15 minutes later, it was gone. So that was our moment to make the measurement. And it was extremely exciting to know that we'd actually been able to.
One day, not long from now, these scientists hope to see the monster directly by linking observatories around the world in a giant telescope powerful enough to peer deep into the center of the galaxy. What they will see is a dark spectre framed by flashes of light. These are just flares compared with the monumental eruptions of its past.
Our black hole had a wild teenage life, I'm pretty sure of that. It probably had jets, it threw lots of matter out, it had a grand old time, and now it's decayed into the old folks' home of the galaxy.
But what would it take for the monster of the Milky Way to awaken? Could explosive jets of energy once again blast across our galaxy? The watch is on at the very ends of the Earth. Astronomers have come to the South Pole to monitor radio signals from the galactic center. They can see signs of a disaster in the making. A vast ring of gas is looming just beyond the Milky Way's central black hole. In time, it will accumulate 300 million suns worth. When the ring reaches a tipping point, it will begin to funnel into a second ring that orbits close to the center. The inner ring will condense into a giant cloud. Within it, a storm of new stars will be born. Then, the gas cloud will begin to spiral down into the grasp of the black hole. When the feasting starts, the eruption will be visible far beyond our galaxy. Our galaxy will survive its black hole's upcoming feast, but it isn't likely to survive a threat further down the road: galactic cannibalism.
Our galaxy, the Milky Way, is not immune from these colliding galaxy scenarios. We've got neighbors. We're falling towards each other. And one day we will collide.
Even now, the end of our galaxy is approaching. Our giant neighbor, the Andromeda Galaxy, is charging toward us. Knowing the galaxy's dimensions, flight paths, and the laws of gravity, scientists can predict how the clash of titans will unfold.
What our simulations show is what could happen basically in quite a few billion years from now, when the two galaxies will actually approach each other and merge.
First, the galaxies will circle and entwine, ripping each other apart.
Imagine what that might look like from another galaxy. They'll see two grand, beautiful spiral galaxies moving towards each other, slowly losing their shape. They'll see new avenues where stars and gas can funnel down towards this newly formed center, feeding this reborn monster.
The collision will send a blizzard of stars and gas billions of kilometers into space. Some will shoot toward the crowded core of the new galaxy, spurring even more massive explosions. Amid the turmoil, our little solar system will be flung into the voids of space or driven into the black hole's jaws.
In the process of merging, there will be a very strong starburst event occurring at the time of the merger, as all of the gas is being funneled and towards the center, as well as the two black holes that are likely to merge will also swallow a lot of this gas. So the black hole in our own Milky Way will ignite, emitting so much energy that all of the gas around it will again be blown away in this very substantial wind, in very substantial outflow.
The Milky Way will be destroyed. But what about the black hole at the center? it will merge with Andromeda's.